A perfect training score? That's usually your first red flag. You must check the locked test data. Or is your model just memorizing?
Hi, welcome back. I hope you're doing well. If you're new to the channel, I'm glad you found this video where we are discussing machine learning foundation concepts. I'll ask you one question. Do you remember in your school days where a teacher gave you a practice test? Let's take maths test. And sneakily, she gave you the same paper in the final exam. How did you score? I'm sure you would have scored well. But the question is, why did you score well? It is not that you understood all the problems, but as the questions were exact, you remembered the answers. So you got a good marks. The same thing can apply to the machine learning models as well. If you are going to test the data on the same data which you trained it on, obviously you are going to get excellent results. This we saw in the last video where we were talking about classification, where both the models got zero error. What does that mean? That means both the models were doing perfectly well in the training data when we trained it and we're testing on the training data. So today we are going to solve that problem. We are going to divide the data, the whole data, not the training data, the whole data we have into three different buckets and use only one part of this bucket for training and keep the other two buckets for testing if the model is doing good. This one is one of the most practical topics in machine learning. Let's get into it. Let's see the image. Practicing for the preparation, exam is for performance. If you are practicing from the last year's exam and you are getting the same paper in this year's exam, obviously you are going to get 100%. But what happens when the real exam changes and you are not getting the same paper for the final exam? So let's find out what happens with the data. First, the algorithm learns from the training data that we have seen both in the classification and the regression, where the training data gives the parameters to the algorithm which creates the models. If you test F on the same training data, that is the model on the same training data, it always looks great. Right? That's what we told. If you train a data and you are going to test on the same training data, it will look good. Now, it has already seen those answers. This is called overfitting. Overfitting means what? It is not guessing and coming to the conclusion, but it already knows the answers. So that is why it is giving you a perfect answer for every question. The real question is, how does F perform on data it has never seen? That is what we are going to do in this video. Got it? So basically, we have a practice paper which the model has already seen. So it is going to perform well. We are going to give it new data which has never seen and then see how good is the model going to perform. What we are going to see is that the model F and model G we used in our video 13, where we were discussing the classification concept. We are going to use it on test data and see if they are going to give both zeros, that is both are going to be perfect, or one model becomes more imperfect than the other. So how do we divide this data what we have? Dividing your data. So we have one large data set. Okay, where do you get this data set? Any normal data set. Like we have been always discussing about the house data set. So let us take the house data set, and the whole data set what we got is the large data set of all available data. So now once we get the data, we divide the data into three parts: training data, validation data, and the test data. The training data algorithm learns from this. What is the meaning of training data? That is what is the data which we give it to the algorithm for it to find the parameters so that we can get models out of the algorithm. Got it? So it is touched by algorithm very much because that is the data which is used by the algorithm to get the parameters to finalize the models. Next comes the validation data. Validation data is little tricky. You just sit upright and listen for 2 minutes. Okay. Used to choose the right type of model. What do you mean by right type of model? See, for example, we had 2 models in the classification discussion. One was related to area and the second one related to price. Okay, so there can be many other different types of models. Okay, we get different models from the algorithm where we have to take, in the case of classification, we have to take both the models because both were perfect, right? But the type of model, for example, we want to look at only the price feature, or we want to take only the area feature, or we want to take only the price plus the distance feature. This selection is done on the validation data. So we give all the models to the validation data, or rather we run the validation data on all the models given by the algorithm and see which type of model consistently performs compared to the other type of models. Got it? There's a slight difference between the validation data and the final data. So that is why I'm taking a little more time to explain to you what is the validation data. First, the training data is plain training data. The algorithm is fully playing with it and gets the parameters and models out of it. Then we have the validation data where the user, the human being in the loop, he decides which type of model we need to choose between all the models given by the algorithm. And the final test data is the final exam. So the models have never seen it during either the training session or the selection session. So the models never see the test data. The test data is sacred. Okay, that is a secret run. Sacred and secret, both. The models never see the test data. Test data is locked away until the very end. Each bucket has one job, never mix them. If you even mistakenly use the test data for selection of the model or getting to choose which model is good, that's it. The test data is contaminated and you cannot use it as test data. Okay, now let's go a little deep into the model selection or the testing of the models with the validation data, because this is a little critical and you have to understand it clearly. So I have made this 3-stage modeling workflow. If you can see, the training data is given here and the algorithm is working and we are getting all these parameters which we have discussed in the regression and the classification models, everything we have spoken about. So you have this B independent parameter, you have the W2, you have the weights for different features. Okay, rooms are features, areas are features, these are all weights. So we get the models here. Algorithm learns here. Okay, validation data, listen carefully, compare models and choose the best. Model A, loss is 0.68, model B is 0.42. Okay, rather than telling it as a model, we usually tell it as model type. Okay, what we are comparing is the type of model. Like for example, if you want to remove only the areas, there was a model which has rooms and areas. The other model had only rooms. Other model has area and distance. Other model had rooms and distance. So which type of model is consistently performing in the validation data, that model type is what we are going to choose. Got it? So that is what happened in the validation status stage or selection stage of the model. The third one is the test. So we run it only once of the model type we have selected. That's it. So if you are going to run it again, then the data gets corrupted. So what you have to do, if you are not happy with the test results, what you are getting from the model selection, you have to go back again to the first. Okay, and again retrain all the models, get the algorithm, and then do the whole process again, and then come to the test data. You cannot by any means use the test data to validate or train. The whole sanctity of the test data gets destructed if you do that. So to drill it down deep into your mind, I will use a simple example. Okay, you are a cricket player. Okay, India is famous for cricket, and you play gully cricket, you play representing your school, etc. Then what happens? Selectors come and you jump into the Ranji Trophy. Right? Ranji Trophy is like a validation data. The school representation, the club representation, all are training data. Okay, you are getting trained. Then you go to the Ranji Trophies. Ranji Trophies are like validation data. There the selectors actually see you play with a different type of a crowd. Okay, then if from there you are still a good player, then you go to the national team and you play the World Cup. Got it? So World Cup is the final test. So you remember like this: the training data, the validation data, and the final test is the test data. I think this would have put the concept of validation right into your brains. Next, we will quickly run through the classifiers what we saw in the last video. What did we do? We took two models. Just to remind you, we had taken two models, F and G. The F model was based on the area, okay, and the G model was based on the price. Okay, so the model F was area minus 10, area minus 10, and the model G was price minus 6. Okay, these were the two models. So we'll see where they got perfect results in all the tests. Both the models got perfect score. So the misclassification error was 0. Now let's see in the test data, model F scores 2 correct and 1 wrong. And model G here scores 2 wrongs and 1 correct. So basically in the training data, both F and G got 0, 0. That means they were perfect. But in testing data, F got 2 correct and G got 1 correct. So model F gets 2 correct and model G gets 1 correct. So the models perform completely different when we give a data which the model has never seen. So that's the strength or the importance of the test data over the training data. Training loss tells you how well the model memorized. Remember this. Training loss only gives how good the model can memorize. The test loss actually tells you how well the model actually performed. That's the difference. The model memorizing and the model learning and performing. In every machine learning system in the real world, be it Google or be it your HDFC Bank or any kind of a big organization, they always divide their data into these three buckets and then get the perfect models for their business or the systems. Okay. Next, we will summarize the video and see what we are going to do in the next video. To summarize what we have seen in this video, never evaluate a model on the data it trained on. Okay, this seems very, very simple and clear, where you are not supposed to evaluate the performance of a model based on the data which it trained on. Second, use validation data to choose the model structure and not test the data. Got it? So, test data is different, validation data is different. Validation data, we are going to find the structure which we are happy with. And that is going to be a human being who is going to do that. Okay? So that is the structure we are going to select on which seems to be performing well consistently. And third, test data is usually used exactly once. The final honest answer. If you are going to do it 2-3 times to select model, that is already contaminated. That is no more a test data. That has already become either validation or worst case, it has become a training data. Okay. Training, algorithm learns the parameters. Validation, human selects the model structure. Test, final unbiased evaluation. That's it. That is as simple as that for the data bifurcation of what we have done today. What we are going to do next is something completely different what we have been doing for the last few weeks. What we have done is basically we have always given a label. Let it be regression, let it be classification. In regression, we gave a number. For example, we gave the price in the housing example. And in case of classification, we gave yes or no, more than or high, lower than, all those things. So we have a choice kind of a selection. We gave a label. But in unsupervised learning, what we are going to give is we are going to take away the right hand side. That means the labels portion we are going to take away, leaving alone the data what we have. And we will understand what we can learn from that kind of a data. Okay, that completes this video, and I hope you enjoyed this video. Like, share, comment, and I will see you in the next video. Thank you so much. Take care. Bye-bye.